Okay, I'll start. So in this video I'm going to talk about convergence of series, right? Convergence of series, and it's a very, very important topic in a UPSC point of view. We can expect a 10-mark question from this topic every year. You can expect a 10-mark question. Maximum 60% we can expect a question from this topic. They will give one series. Now we need to check whether that series is convergent or divergent, right? So actually I have in a real analysis playlist I have already talked about the convergence of sequence and series. So I'm not going to define what's meant by convergence etc. So straight away I'm going to only solve lots of problems, right? So we can in UPSC we will expect only problems. So they will give one series. We need to check whether the series is convergent or divergent. So there are several tests to verify whether the series is convergent or divergent. So we will move on one by one. So first test is comparison test, right? So first I will write what's meant by comparison test, and then we will solve lots of problems based on comparison test, and then we will move on to root test, and then ratio test, and then Gauss test and integral root test. So there are several tests to check whether the series is convergent or divergent. So in this video first I'm going to start with comparison test. So I'll just give the statement of comparison test, and based on the statement we will solve some problems, right? Yes. So I'm assuming that you know what's meant by convergence of sequence, right? So a sequence has to be convergent after some stage. If every term of the sequence approaches a certain number, then we say that it converges to a limit, right? Limit L. And similarly for a series to be convergent, when the partial sums is convergent, then we say the series is convergent. So just go through the definition that I already taught in analysis playlist, right? Yes. So in this video first I will give you one theorem before getting into the comparison test. So our aim is they will give one series. You know what's the series, right? So for example 1 by 2 plus 1 by 3 and so on. So they will give one series. We need to check whether the series is convergent or divergent. So before getting into that, let us recall one very important theorem, that if a series summation un is convergent, suppose if the series summation un is the nth term of the series. If a series summation un is convergent, then limit n tends to infinity an is equal to 0. So very, very important theorem. So whenever a series is convergent, then the limit of the sequence as n tends to infinity will be 0, right? So whenever a series is convergent, if a series summation un is convergent, then limit n tends to infinity an is equal to 0, right? The converse not true. If then, so converse not true, that is if limit n tends to infinity an is equal to 0, then the series may or may not be convergent. If it is convergent, then limit will be equal to 0 as n tends to infinity. Suppose if this happens, it is not necessary that the series has to be convergent, right? If limit n tends to n is equal to 0, may or may not be convergent, but what we can infer from this theorem is that if a series is convergent, then limit n tends to infinity n is equal to 0. If limit n tends to infinity an is not equal to 0, then series summation un is not convergent. This is a very, very important point that I am talking about, right? So if nth term of a series does not tends to 0, then the series will not convergent, right? I am just contradicting the statement. If the series summation un is convergent, then this will happen. Suppose this is not happen, this will not happen, right? That is, if limit n tends to infinity an is not equal to 0, let us say it's un, right? Un. Then the summation in a series summation un is not convergent. So whenever they give a series, you just check whether limit n tends to infinity n is equal to 0. If that happens, then we can check whether it's convergent or divergent. Suppose if it is not equal to 0, at a single line you can just say the series is not convergent, right? So if the series is convergent, then this will happen. Suppose if this happens, may or may not be convergent, right? So suppose in the exam they will give one series. Now just find the nth term of the series, and you find the limit n tends to infinity, and if it is equal to 0, then you can use your test, because it may or may not be convergent. Now you can use the test like comparison test or Gauss test, root test, etc. But if it is not equal to 0, then it is not, then the series is not convergent, right? So the series summation is convergent, then limit n tends to infinity, and this is the un. If the un is equal to 0, then it is convergent, right? The converse is not true, right? Converse is not true. For converse, you can just take a sequence, series. Let us take a series summation 1 by n, right? So this series, you can see our un is 1 by n here. Now limit n tends to infinity un is nothing but limit n tends to infinity 1 by n, which is equal to 0. So if it is equal to 0, but the series is not convergent, that this we will prove later. The series summation 1 by n is not convergent. As a sequence 1 by n is convergent, but as a series summation 1 by n is not convergent. So you just find for a given series, you just find limit n tends to infinity un is un, and if it is equal to 0, then may or may not be convergent. Then we need to use of this test to check whether it is convergent or divergent. If it is not equal to 0, then series summation un is not convergent. And you just take another note that the series summation 1 by n power p is convergent. The series summation 1 by n power p, right? N power p is convergent if p is strictly greater than 1, right? Convergent if p is strictly greater than 1, and if it is, and it will be divergent if p is less than or equal to 1, right? So series summation 1 by n power p. For example, just now we have saw summation 1 by n is divergent because where p is 1 here, so p is less than or equal to 1, it is divergent. So you just make very important series. It is called harmonic series. So harmonic series summation 1 by n power p is convergent if p is greater than 1, and it is divergent if p is less than or equal to 1, right? Now we will move on to comparison test, right? So comparison test is a very important test. The first that we are going to talk about comparison test. So these are the fundamentals for a convergence of series. Now we will move on to comparison test. Based on comparison test, we will work out many problems. So comparison test. If summation un and bn be two positive term series, right? So un is a given series, right? Un is a given series. Now you find another series bn inside un, right? You need to find another series bn inside un, right? Now when we work out problems, it will be more clear. So un is a given series, and you just have to find bn which is from un. First case, if limit n tends to infinity un by bn, if it is equal to 1, that is if it is finite and non-zero, then summation un and bn both convergent or divergent together. Then summation un and summation bn both converge or diverge together. Very important result, right? If un is a given series, so let us given summation un. You need to find another series vn from un, right, from un, and you just find limit n tends to infinity un by vn. If it is finite and non-zero, then both un and vn converge or diverge together. Now second is, if limit n tends to infinity un by vn is equal to 0 and summation vn converges, then summation un also converges. Summation un is also convergence. Now third is, if limit n tends to infinity un by vn, if it is equal to infinity and summation vn diverges, then summation un also diverges, right? So very important. Three comparison tests, very important. So based on this result, you will work out problems, right? So given a series un, you need to find another series vn from un, and you find the limit un by vn. If it is finite and non-zero, both un and vn converge or diverge together. If vn is convergent, un is also convergent. If un is convergent, vn is also divergent. If this is divergent, this is also divergent. Both converge or diverge together. If limit is equal to 0 and if summation vn converges, then un also converges. And if it is equal to infinity, then vn diverges, then un also diverges. So just make a very important note and just make some boxes for the comparison test. Now we will work out the problems based on comparison test. The only thing is, un is given, find vn from the given series un, right? You need to find vn. Now there is a trick to find vn. I will tell that in doing problems, right? Yes. And another important result just now I quoted is summation 1 by n power p is convergent if and only if p is strictly greater than 1, and it is divergent if p is less than or equal to 1, right? So based on this, now we will work out right, summation vn diverges and un also diverges. Now we will work out some problems based on this comparison test. Now important thing is, un is a given series, we need to find vn from un, and you just make use of this result. If it is 1, both converge or diverge together. So discuss the convergence of the following series. Discuss the convergence of following series, right? The first problem is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on. Now whenever they are given the series, first you have to write the nth term. So what is the nth term? You can see this is the term for n is equal to 1, this is the term for n is equal to 2, this is the term for n is equal to 3 and so on. Now you just have to find summation un, right? So what is our un? Now clearly what will be our series? So it is nothing but, you can see 1 is everywhere, so numerator will be 1. Now here you can see 1, 2, 3. So this is the term for n is equal to 1, this is the term for n is equal to 2, this is the term for n is equal to 3. The first term is n into n plus 1, right? Summation n is equal to 1 to infinity. Now you can see if n is equal to 1, you will get this term. If n is equal to 2, we will get this term, and n is equal to 3, we will get this term, and since it is summation, we will have plus between them. Now what is our un? So our un is 1 by n into n plus 1, right? We need to find vn. We need to find vn from un, right? So summation un is given. So we have un is the nth term of the series. We need to find vn, right? So what you have to for vn, what you have to do is, you have to take okay, just if we simplify this, what you will have, this will be n square plus n, right? So if I substitute n, sorry, if I multiply n, we will have n square plus n, and if I take n square common, here you will have 1 plus 1 by n, right? Now you take Vn is equal to 1 by n square. Now you always have to take, you always have to bring the highest power inside, and then you have to take always this term as Vn, always have to take this term as Vn, right? I'll repeat, you should always take the highest term common. So here the highest term is n square, so I'm taking n square common. So if I take n square common, it will be 1 plus 1 by n. Now you take Vn as 1 by n square. So here we will have, so we have Un and here we have Vn. You should always find Un, sorry, you should always find Vn from Un. So the important trick for finding Vn is, you just take the highest power common and you just take 1 by highest power as Vn, right? You can take Vn to be anything, right? Yes. Now we have found Un and Vn. Now what will be my limit n tends to infinity Un by Vn? What will be my limit n tends to infinity Un by Vn? So limit n tends to infinity Un by Vn. So limit n tends to infinity. So what is Un? Un is 1 by n into n plus 1 divided by, and what is Vn? It is 1 by n square. It is 1 by n square, right? Okay. So we have found Un and Vn. Now you just find limit n tends to infinity Un by Vn. So Un is 1 by n into n plus 1 and Vn is 1 by n square. Now if I simplify this, we will have limit n tends to infinity. So if I 1 by n square will go to numerator, we will have n square by n into n plus 1, and this is nothing but, if I cancel 1n, we will have limit n tends to infinity n by n plus 1, and as n tends to infinity, this tends to 1, right? This tends to 1 because I'll just write here. So limit n tends to infinity n by n plus 1. So in denominator I can take n common, so we will have 1 plus 1 by n, and this n will get cancelled. As n tends to infinity, 1 by n tends to 0, so this will be equal to 1 by 1 plus 0, which is equal to 1, right? Now you can see this satisfies the first condition. Un and Vn be two positive number sequence, and limit n tends to infinity Un by n is equal to 1. So here we have 1. So therefore, if it is equal to 1, both Un and Vn both converge or both diverge, right? Both converge or both diverge. Now what is Vn here? What this says is, if it is equal to 1 and if it is equal to 1, then both Un and Vh both converge or both diverge. Here what is summation Vn, which is summation, we have taken Vn to be 1 by n square, which is 1 by n square. This is convergent. Why? Because just now we have seen the harmonic series, summation 1 by n power p is convergent if p is greater than or equal to, sorry, p is strictly greater than 1. So here it is p is equal to 2, so therefore it is convergent. So since summation Vn is convergent, summation Un is also convergent. Why? Because by comparison test, both Un and Vh converge or diverge together. This is very important. This word is very important. If summation Vn is convergent, Un is also convergent, because if this condition is satisfied, both converge or diverge together. So if summation Vn is convergent, Un is also convergent. If summation Vn is divergent, suppose if I have Vn to be equal to 1 by n, that will be divergent, because Un will be divergent, because summation Vn is divergent, right? Suppose if I have Vn to be equal to, suppose if I have summation Vn to be equal to 1 by n, then Vn is divergent, because 1 by n is, summation 1 by n is divergent, therefore summation Un also is divergent by this test. But since summation Vn is convergent, Un is also convergent, so therefore this series is convergent. I'll repeat. So you just find the nth term for a given series, and you just find Vn by taking the highest term in the denominator, and you always take Vn in terms of 1 by n power p, right? You should always take Vn in terms of 1 by n power p when you have to apply comparison test, right? You always choose Vn in terms of 1 by n power p. So So here Vn is 1 by n square. Now you find limit n tends to infinity Un by Vn, which we got as 1. Therefore from this result we can conclude both converge or diverge together. Since summation Vn is convergent, Un is also convergent. So therefore the given series is convergent. Right. So just make use of this result. So I'll just erase the results. Now we'll work out more problems. So I'll just write it down here. Comparison test. Right. So given series is summation Un. Find summation Vn from Un. Find Vn. Okay, so find summation Vn from summation Un, and you find limit n tends to infinity Un by Vn. If it is equal to 1, both summation Vn and summation Un converge or diverge together. Right, both converge or diverge together. Now we will work out the second problem. Second problem is 1 by 1 into 4. Actually the heading is discuss the convergence of series. So second problem is 1 by, we can expect in 10 marks 1 by 2 into 5 plus 1 by 3 into 6 and so on. Right. Now first we need to find the nth term, that is we need to find summation Un. N is equal to 1 to infinity. Now what this Un will be? So you can see 1 is in the denominator for every term, and here you can see this is into. So this is for n is equal to 1, this is for n is equal to 2, this is for n is equal to 3, and you can see this is 1, 2, 3. So here we will have n. So if n is equal to 1, we will have 1. If n is equal to 2, here we will have 2. Now here we will see 4, 5, 6 and so on. So what is the nth term for 4, 5, 6? Right, 4, 5, 6. Right. Now we need to find the nth term for 4, 5 and 6. Okay, I'll give you one shortcut for writing the nth term. So you just collect all the first term. So first term is 1, 2, 3, etc. And you collect all the second terms, which is 4, 5, 6, etc. Right. So 1 into 2 into 3. You just collect all the first terms 1, 2, 3, etc. And you collect all the second terms for 4, 5, 6, etc. Now you find the nth term for 1, 2, 3, 1, 2, 3 and so on. So what is nth term? A plus n minus 1t, right? A plus n minus 1t. So here A is 1 and D is also 1, because common difference is 1 again. So which is 1 plus n minus 1, which is equal to n. So we will have 1 by n. Now here we will find nth term for 4, 5, 6, 4, 5, 6, etc. So 4, 5, 6 and so on. So nth term is A plus n minus 1t. So here A is the first term, which is 4. We keep n as it is. Common difference is 1. So we will have 4 plus n minus 1. So which is n plus 3. Right? N plus 3. So this will be n into n plus 3. So this is the nth term for given series. Right? So just collect all the first term and apply the formula A plus n minus 1d. You will get or else you can also use trial and error method to easily find the nth term of the series. Now if you substitute n is equal to 1, you will have 1 by 1 in 1 by 1 plus 3 is 4. So we will get the first term. If n is equal to 2, here we will have 1 by 2 into 2 plus 3, which is 5. So we will get the second term. So here our Un is 1 by n into n plus 3. Now we need to find Bn from Un. As I said earlier, you just take the highest degree common in the denominator. So this will be 1 by n square plus 3n. So I have just multiplied n square or n. So if I take n square common, here you will have 1 plus 3 by n. So take Bn is equal to 1 by n square. So we have un and we have vn. Now you find limit n tends to infinity un by vn. So this will be limit n tends to infinity. Our un is 1 by n into n plus 3, or else we can also take un to be this term, because this term is nothing but simplification of this term. We just take un to be 1 by n square plus 3 by n, and vn is 1 by n square, right? So this 1 by n square, this 1 by n square will get cancelled. So this will be, as n tends to infinity, 3 by n tends to 0. So we will have 1 plus 0, which is equal to 1, right? So you can see this is equal to 1. So both summation vn and un converge or diverge together. So since summation vn, so what is summation vn? Vn is 1 by n square. This is convergent. Why? Because summation 1 by n power p is convergent if p is strictly greater than 1. So here p is equal to 2, which is greater than 1. So therefore the given therefore summation vn is convergent. Since summation vn is convergent, summation un is also convergent by comparison test, right? So since both vn and un converge or diverge together, so since summation vn is convergent, un is also convergent. So therefore this series is convergent. What's the third problem? So depending upon the series summation vn, we can predict whether the given series un is convergent or divergent. If the given series, if the summation vn is divergent, then un is also divergent. If summation vn is convergent, then summation un is also convergent. So third problem. So third problem is 1 by 1 into 2 into 3, 1 by 2 into 3 into 4, plus 1 by 3 into 4 into 5, and so on. Now I can clearly find the nth term of the series. So nth term is nothing but n plus 1, n plus 2, right? Again, if I see n is 2 here, so n plus 1, n plus 2, or else you can also write the method that is set in the previous problem. So for finding summation un, so you just collect all the first term, so 1 into 2 into 3 and so on. You got all the second term, which is 2 into 3 into 4 and so on. You got all the third term, which is 3 into 4 into 5 and so on, right? 3, I'm collecting all the second term, so 2, 3, 4, etc. and collect all the third term, so 3, 4, 5 and so on. Now you find the nth term by using the formula a plus n minus 1 d. So here a is 1, a plus n minus 1, d is also 1, because common difference is 1. Now which is nothing but n. So this will be 1 by n. And here first term is 2, common difference is 1. So 2 plus n minus 1, which is n plus 1. And here the first term is 3, so a plus n minus 1 d. So this will be 3 and this will be n plus 2. So this is our summation un. So if n is equal to 1, we will get the first term. If n is equal to 2, we will get the second term, and so on. Now what is un here? So un is 1 by n into n plus 1, n plus 2. Now in order to find vn, you should always take the maximum degree in the denominator. Here the maximum degree for n is n cube, right? So before that, what we will do is, so let us take n common here. So we will have 1 plus 1 by n. So I am taking n common in n plus 1. So if I take n common, you will have 1, and this will be 1 plus 1 by n. And if I take n common from n plus 2, you will have 1 plus 2 by n. So this is nothing but 1 by n cube into 1 plus 1 by n, 1 plus 2 by n. This is our un. Now take vn as the highest term in the denominator. So take vn is equal to 1 by n cube, right? Now you find limit n tends to infinity un by vn. So limit n tends to infinity un by vn. So un, you can take Instead of taking this as union, you can take this as union, because this is nothing but simplification of this term. So this is nothing but 1 by n cube into 1 plus 1 by n 1 plus 2 by n divided by 1 by n cube, because Vn is 1 by n cube. So this 1 by n cube, this 1 by n cube will get cancelled. So we have, this will be equal to limit n tends to infinity, n tends to infinity. This, it is not that it is 1, it can be any finite number, right? Any finite number, finite and non-zero. So finite are not equal to 0. It is not that it always has to be equal to 1, it can be any finite number, it can be 1, 2, 3, 4, etc. So this will be, as n tends to infinity, this will tend to 1 by 2, right? This will tend to this will tend to, you can see as n tends to infinity, this will be 1 by 1 plus 0 into 1 plus 0, where it is equal to 1 here, right? So therefore both summation un and summation bn, both un behave alike. So therefore you can see this series is convergent. As a series, summation 1 by n cube is convergent, because summation 1 by n power p is convergent if p is strictly greater than 1. So since summation 1 by n cube is convergent, the given c is also convergent. Summation un is also convergent. That's it, right? Therefore this series is convergent. So now we'll move on to the next problem. We will do fourth problem now. So just have to take Bn from Un in like 1 by n power p. You just take Bn as in the format 1 by n power p. Discuss the convergence messages. We will move on to the fourth problem. So 1 by 1 into 3 plus 2 by 3 into 5 plus 3 by 5 into 7 and so on. Okay. So first we will find the nth term of the series. We will find the nth term of the series. So what is summation un? So this is nothing but summation. You can see that in numerator also the term is changing. So in numerator we will have 1 into 2 into 3 and so on. And the first term we will have 1, 3, 5 and so on. And second term we will have 3, 5, 7 and so on. So what will be my nth term? So for numerator it is nothing but n. So here 1, 3, 5 and so on. So a is a plus n minus 1d. So a is 1, which is the first term, d is 2, common difference is 2. This is nothing but 1 plus 2n minus 2, so which is nothing but 2n plus 1. So this is nothing but 2n plus 1, and here we will have 3, 5, 7 and so on. So a is 3, a plus n minus 1d, so d is 2. So we will have 3 plus 2n minus 2, which is 2n, sorry, this 2n minus 1. This is 2n minus 1, and this is 2n plus 1, right? 2n plus 1. So we have found the nth term of the series, which is summation n by 2n minus 1 into 2n plus 1. That is, our un is n by 2n minus 1 into 2n plus 1. Now we will take the highest degree common. We will take the highest degree common now. So before that we will simplify this. So this will be 1 by, so if I take n common here, we will have 2 minus 1 by n, and if I take n common here, we will have 2 plus 1 by n. So 1 n will get cancelled. So we will have 1 by n into 2 minus 1 by n, 2 plus 1 by n. Now always take Bn as 1 by n power p. So just take Vn is equal to 1 by n, right? Vn is 1 by n. The previous term we will have 1 by n square, 1 by n cube and so on. Here we will have 1 by n. Now what about limit n tends to infinity, un by Vn? It is nothing but limit n tends to infinity. Our un is 1 by n, 2 minus 1 by n, 2 plus 1 by n divided by 1 by n. So this 1 by 1 will get cancelled. So we will have 1 by 2 minus 1 by n into 2 plus 1 by n. So as n tends to infinity, this tends to 0, this tends to 0. So we will have 1 by 2 into 2, which is 1 by 4, which is finite and non-zero, right? Which is finite and non-zero. So both un and vn converge or diverge together. Now since summation vn is divergent, why? Because you can see our vn is 1 by n and summation vn is 1 by n, and this is divergent because this will be convergent if p is strictly greater than 1. Here p is equal to 1, therefore this is divergent. So since this is divergent, therefore summation un is also divergent, right? So therefore this series is divergent, right? Divergent. So depending upon the nature of Vn, we can predict the nature of Un. Let me give you one more problem. The fifth problem. Fifth problem is 1 by 3 square into 2 by 4 square plus 3 by 5 square into 4 by 6 square plus 5 by 7 square into 6 by 8 square and so on. So this is a series. We need to check whether the series is convergent or divergent, right? This we need to check whether it is convergent or divergent. So before that, we will find the nth term, and you can see the nth term is summation un is summation. So in the numerator we will have two terms. So we collect all the first terms. So first term is 1, and then 3, and so on, and then 5, and so on. And second term is 2, 4, 6, and so on, divided by, you get all the first term here. So 3 square, 5 square, and 7 square, and so on, and all the second term. So 4 square, and 6 square, and 8 square, and so on, right? Now you just find the nth term. So here a is 1, a plus n minus 1d. So a is 1, so a is 1, and d is 2. So a plus n minus 1d. So this is nothing but 1 plus n minus 1 into 2. So 1 plus 2n minus 2, which is nothing but 2n minus 1. This is nothing but 2n minus 1. And here this is nothing but 2n, right? Because you can see, if n is equal to 1, it is 2. If n is equal to 2, it is 4. If n is equal to 3, it is 3. Or else we can also use the formula. So 2, 4, 6, and so on. So a is equal to 2, and d is also equal to 2. So a plus n minus 1d. This will be 2 plus n minus 1d. So 2 plus 2n minus 2. So 2 will get cancelled. So we will have 2n divided by we have square overall here. So 3, 5, 7, and so on. So again for here a is 3 and d is 2. So this will be 3 plus n minus 1, 2. This is 3, and then this is nothing but 2n plus 1 whole square. And because we have square in each term. And again this is nothing but our n is a is 4 and d is 2. So it will be 4, and this will be 4, and this will be 4, and this will be 2n plus 2, right? 2n plus 2. So 2n plus 2 whole square. This is the nth term of the series, right? So it is very easy. The only thing is you need to apply a plus n minus 1d formula for each terms. So our un is 2n minus 1 into 2n divided by 2n plus 1 whole square into 2n plus 2 whole square. So this is our un. Now we need to find bn. So before finding bn, we will simplify this. So simplify this, you can see, so let us say this 2n minus 1 into 2n. You have to take highest degree common here. So what is highest degree? N. I can take n square common here, right? So if I take n square common, if I take n common, you will have, because I can take n common here, since we have square, I can take n square common. So this is nothing but 2 plus 1 by n whole square, right? 2 plus 1 by n whole square. Again, if I take n common here, if I bring in outside, we will have to bring with square term. So we will have n square 2 plus 2 by n whole square, right? Yes. So in the numerator, I can take the numerator is nothing but I can take n common here. So if I take n common here, we will have 2 minus 1 by n into 2n divided by, so this is nothing but here we will have n power 4 2 plus 1 by n whole square 2 plus 2 by n whole square. Now we can see this n into n is n square, so this n square and 1 n square will get cancelled. So we have left with, here we will have the numerator, we will have 2 minus 1 by n divided by, here we will have 1 n square, right? 1 n square, because here n power 4, here n square will get cancelled. So here also have 2 here. So 2 into 2 minus 1 by n. So this n square and this n power 4 will get cancelled. Remaining we have left with is 2 plus 1 by n whole square 2 plus 2 by n whole square, right? Now you just take bn to be equal to 1 by n square, or you can also take 2 by n square, not at all a problem. So take bn, take bn is equal to 1 by n square. You always choose bn in the format 1 by n power p. So here I have taken bn to be equal to 1 by n square. Now you find limit n tends to infinity un by bn. So this is nothing but limit n tends to infinity. So what is un? You can straight away take this as un, because the simplification of this is this. So we will have 2 into 2 minus 1 by n square 2 plus 1 by n whole square 2 plus 2 by n whole square divided by bn. So divided by bn is, if I take that to numerator, we will have n square, and this n square will get cancelled. Now as n tends to infinity, this tends to 0. So in the numerator we will have 2 minus 2 minus 0. So 2 into 2 minus 0, and here you will have this tends to 0. So 2 plus 0 whole square and 2 plus 0 whole square, right? So we have left with 4 by, and this is 2 square is 4, 2 square is 4 again. So 4 and 4 is 16. So this is nothing but 1 by 4, nothing but 1 by 4, which is finite and non-zero, which is finite and non-zero. So therefore if summation b, since it is equal to finite and non-zero, if un is convergent, bn is also, if bn is divergent, un is also convergent. So what is our bn? Our bn is 1 by n square, 1 by n square. So since, I write it here, since summation bn is convergent, why? Because summation 1 by n square is convergent, summation 1 by n power p is convergent if p is still greater than 1. So here we have 1 by n square. So since summation bn is convergent, summation un is also convergent. Suppose if this is divergent, then un is also divergent. So therefore summation un is also convergent. So therefore the series is convergent, right? So actually very easy. You just have to find the nth term. After finding nth term, you simplify, and then you find bn, and you find limit n tends to infinity un by bn. And if it is finite and non-zero, both un and bn converge or diverge together. And since we have taken bn to be equal to 1 by n square, and the important thing is you have to take bn as the highest power in the denominator, and then you just find, okay. So we will move on to the 6th problem. So today what we are doing is we are only solving the problem based on comparison test, right? So next upcoming videos we will do one by one, and then we will finalize overall. So for which problem, for which test you have to apply, I will give one overall overview for after completing all the tests, right? So today we are only focusing on comparison test, right? We can also use the same, we can also approach this same problem by some other test also, but I will deal that later. Now we will move on to sixth problem. Sixth problem is 1 by root 1 plus root 2 plus 1 by root 2 plus root 3 plus 1 by root 3 plus root 4 and so on. Right, this is our series. We need to check whether the series is convergent or divergent. Now we can straight away write the nth term. So un is nothing but summation, and you can see 1 is in the numerator, so 1, and this is nothing but root n plus root n plus 1. Right? So for n is equal to 1 we have 2, for n is equal to 2 we have 3. So this, or you can also use the nth term as I said earlier, a plus n minus 1t. So 1, 2, 3, we just take root common, 1, 2, 3, which is nothing but n, and 2, 3, 4, which is nothing but n plus 1. So we have un as 1 by root n plus root n plus 1. So this is our un. Now we need to find bn. So for that we need to take the highest power. So I am taking, or else you can also take a conjugate. Okay, no problem. So let us take root n as it is. Now if I take root n common here, we will have root 1 plus 1 by n, right? I have taken n out. If I take n outside, we have to take root n outside. So if I take root n common here, we will have root of 1 plus 1 by n. So again I can take 1 by root n common, so which is nothing but 1 plus square root of 1 plus 1 by n. Right? Now you take Vn is equal to 1 by root n, that is our Vn is 1 by n power 1 by 2. Right? You can always choose Vn as 1 by n power p, and p can be any number. So here I have taken Vn as 1 by n power 1 by root n, right? 1 by root n. Now what about limit n tends to infinity un by Vn? This is nothing but limit n tends to infinity. Our un is, you can take straight away take this term as un. So 1 by root n, 1 plus square root of 1 plus 1 by n into by Vn. So if I bring that to numerator, we will have root n, right? Because Vn is 1 by root n. So this root n and this root n will get cancelled. So as n tends to infinity, this will be 1 plus square root of 1 plus 0, because 1 by n, as n tends to infinity is 0, so which is nothing but 1 by 1 plus square root of 1, which is again 1 by 2, right? 1 by 2, which is finite and non-zero. So both un and Vn converge or diverge together. So since what is summation Vn, which is summation 1 by n power 1 by 2, this is divergent. Why? Because this is convergent, p is strictly greater than 1, because here p is 1 by 2 here, therefore this is divergent. So therefore this is also divergent. So this implies summation un is also divergent, because by comparison test both are converged or diverge together. If one is convergent, another is also convergent. If one is divergent, another is also divergent. So since the given summation Vn is divergent, the given series also divergent. Why this is divergent? Because summation 1 by n power p is convergent if and only if p is strictly greater than 1. If and only if p is strictly greater than 1. Here we will have p is less than 1, which is 1 by 2 in this case. Therefore the given series is divergent. Move on to seventh problem. root 1 by 4 plus root 2 by 6 plus root 3 by 8 and so on. They have also given the nth term also. In the previous 6 problems, they haven't given the nth term. They have only given the first 3 terms and dot dot dot. Now they also given the nth term also in this problem, which is n by 2 into n plus 1. Right? They also given the nth term also. So it is not it is easy for us to write the nth term straight away. We no need to find the nth term. You can also find nth term very easily by a plus n minus 1d formula. So here we have un is 1 by here we have un is square root of n by 2 into n plus 1. Right? So we need to simplify this and then we need to find Vn, Before that you can see so what is limit n tends to infinity? Actually I forgot to do one thing. So for all the un, you just find limit n tends to infinity un. In the 6 problem that we did earlier, you just find limit n tends to infinity un at the very beginning. You will get 0 for all the terms, right? So if it is 0 only, then we can go for comparison test. If it is not equal to 0, then it is not convergent, right? Yes. Now limit n tends to infinity un. So what is limit n tends to infinity un? So this is nothing but n. Now if you take n common here, we will have 1 plus 1 by n. So this n will get cancelled. So as n tends to infinity, this tends to root 1 by 2, right? Which is not equal to 0. So therefore, the necessary and sufficient condition for series to be convergent is that limit n tends to infinity has to be equal to 0. If it is 0 only, then we can apply some other test. That is what I have said in the very beginning of the video. Actually, you need to check this condition before getting into comparison test. Actually, I forgot to do that. So what you do is for all the 6 problems, here after finding un, you just verify that limit n tends to infinity un is equal to 0. If it is equal to 0 only, then we can then it may or may not be convergent, right? So if it is not equal to 0, surely it will not convergent. So for the 6 problems, we will get limit n tends to infinity un to be equal to 0. But for all the 6 problems that we did earlier, you will get limit n tends to infinity un is equal to 0. If it is equal to 0, that may or may not be convergent. We also have one problem that is equal to divergent. So that is also limit n tends to infinity un is equal to 0. It may or may not be convergent. So but if it is not equal to 0, so since limit n tends to infinity un is not equal to 0, not convergent, right? So we don't need to apply comparison test here. So we can apply a comparison test if and only if we can apply any test if and only if this is equal to 0, right? If it is equal to 0 only, then it may or may not be convergent. We need to check whether it is convergent or divergent. But if it is not equal to 0, you can simply straight away say that it is not convergent. If limit n tends to be is equal to 0 only, then then the series may or may not be convergent. It can be convergent or divergent. But if it is not equal to 0, it will not be. Surely it is not convergent. Okay. Now we will do some more problems. 8th problem. 8th problem is one by a into 1 square plus b, 1 by a into 2 square plus b plus 1 by a into 3 square plus b and so on, right? Here you can see a and b are fixed here. Now what will be un? Can easily see a and b are in each term. So here the only thing that varying is n, right? If n is equal to 1, it is 1 square. If n is equal to 2, it is 2 square. And if n is equal to 3, it is 3 square. So therefore summation un will be summation 1 by a into n square plus b, a into n square plus b. So our un is 1 by a n square plus b, and you can see this is equal to 0. So limit n tends to infinity, un, this will be 1 by infinity, this will be 0, right? So therefore the given series may or may not be convergent. The previous problem we have not got 0, we have got root 1 by 2, so therefore we can conclude that it is not convergent. But here it may or may not be convergent. So therefore may or may not be convergent. It can be convergent or it can be divergent. May not be convergent. Now we will apply a comparison test to show whether this series is convergent or divergent. So what is, you just take the highest degree common, which is n square here. So we will have a plus b by n square. I will take vn is equal to 1 by n square. Now what about limit n tends to infinity, un by vn? So it is nothing but limit n tends to infinity. So un, you can straight away take un as 1 by n square a plus b by n square divided by vn is 1 by n square again. This two will get cancelled. So as n tends to infinity, this tends to 0. So we will have only a, which is finite and non-zero, right? Which is finite and non-zero. Sorry. 1 by n square a plus b by n, so it is a denominator. So we will have, this is equal to 1 by a, 1 by a, which is finite and non-zero. Actually in the question they have to mention that a is not equal to 0, then only this is valid. So this is finite and non-zero. So both the un and vn behave alike. So since summation vn, which is summation 1 by n square, is convergent, because summation 1 by n power p is convergent if p is greater than 1. Since this is convergent, un also convergent because both behave alike. So therefore summation un is also convergent, right? So if limit n tends to infinity, un by vn is finite and non-zero, both behave alike, right? Yes. Now we'll move on to 9th problem. One by 1 power p plus 1 by 3 power p plus 1 by 5 power p and so on, right? 1 by 7 power p and so on, right? You can see this is nothing but odd terms, which is nothing but 2n minus 1, 2n minus 1, or else you can also verify 1, 3, 5, 7, etc. a is 1 and d is 2, so we will have 1 plus 2n minus 2, which is 2n minus 1. So this series is nothing but summation un is nothing but summation 1 by 2n minus 1 whole power p, right? 2n minus 1 whole power p. And you can see limit n tends to infinity, un is equal to 0, right? So what is our un? Un is 1 by 2n minus 1 whole power p, and actually this I have forgot to write this in the first 6 problem. So limit n tends to infinity un, which is 0, right? As n tends to infinity, this will be 1 by infinity, which is 0. But therefore the given series may or may not be convergent. Surely we cannot say it is convergent at this point of view. Suppose if it is not equal to 0, then we can say it is not convergent. Okay, now we will find vn. So before that you will simplify this. So I will take n power p outside. The p can be any number, so p is greater than 0. P can be any number which is greater than 0. Okay, and there is no restrictions on p can be anything. So we take np common, we will have 2 minus 1 by n whole power p. Now just take vn. Vn is equal to 1 by n power p. And by n, in the previous problem we will have 2 square, cube, etc. Here we will have p as it is. Now what about limit n tends to infinity un by vn? So this is nothing but limit n tends to infinity. So un is 1 by n power p, 2 minus 1 by n whole power p. this is 1 by n power p, this 2 will get cancelled. So we will, this is nothing but 1 by 2, right? So we will have 1 by 2 minus 1 by n. So 1 by n tends to 0 as n tends to infinity. So this will lead to 1 by 2 power p, right? 1 by 2 power p. We will have 1 by 2 power p, yes. So finite and non-zero, which is finite and not equal to 0. So both behave alike. So summation, what is summation bn? So summation bn is summation 1 by n power p. We are bn is 1 by n power p. And this is when this will be convergent, and this will be convergent. This will be convergent if p is strictly greater than 1. P is strictly greater than 1. So if p is strictly greater than 1, then Vn is convergent. Therefore Un has to be convergent because by comparison test. So Un will be convergent, right? So this problem we can divide this into two parts. If p is strictly greater than 1, the series is convergent. If p is strictly less than 1, the series is divergent. Suppose if I have 1 by 1 power 1 by 2, 3 power 1 by 2, 5 power 1 by 2, then this series will be divergent, right? So you have to say, in exam they will ask for what values of p this series is convergent. So the series is convergent if p is strictly greater than 1. For what values of p the series is divergent, you need to write if p is strictly less than 1, then the series will be divergent. So they will ask for what values of p this series is convergent. So we have taken bn, we have an to be equal to 1 by n power p, and we have one. We know that summation 1 by n power p is convergent if p is strictly greater than 1, and since this is finite and non-zero, both bn and un behave alike. So therefore if this is convergent, un is also convergent, and this is convergent if p is strictly greater than 1. So therefore summation un will be convergent if p is strictly greater than 1, right? Summation un is will be convergent if p is strictly greater than 1. Okay, so now we will move on to 10th problem. Again, for what values of p the series is convergent? For what values of p the series is convergent? Series is 2 by 1 power p plus 3 by 2 power p plus 4 by 3 power p plus 5 by 4 power p and so on. You can clearly see the series summation un is nothing but un is summation n plus 1 by n power p, right? So if n is equal to 1, you will have 2, for 2 here you will have 3, for 3 you will have 4. So our un is n plus 1 by n power p. Now you have to simplify this, right? So just take n common. So here you will have 1 plus 1 by n, here you will have n power p, and you just take n to the denominator. So you will have 1 plus 1 by n power p minus 1, right? I have just taken this n to denominator. Now you take vn. Take vn is equal to 1 by n power p minus 1, 1 by n power p minus 1. Now what about limit n tends to infinity un by vn? So this is nothing but limit n tends to infinity un is nothing but 1 plus 1 by n power p minus 1 into vn. So I will take vn to numerator, you will have n power p minus 1. Okay. So which is finite and non-zero. So I have taken vn to be 1 by n power p minus 1. So we have n here, I have taken n in the numerator common, so we will have 1 plus 1 by n, and I have taken n to denominator, we have n power p minus 1. I am taking vn to be 1 by n power p minus 1, and you can see limit n tends to infinity un by vn is equal to finite and non-zero. So therefore the series is convergent if summation vn is convergent if what is summation vn? summation 1 by n power p minus 1 is convergent, right? Right. So suppose if this is convergent, the series summation vn is convergent, then un is also convergent because it is finite and non-zero. Now when this will be convergent? Now summation 1 by n power p minus 1 is convergent if and only if the numerator has to be strictly greater than 1. If and only if p minus 1 has to be strictly greater than 1. And see, if you have p here, the numerator has to be greater than 1. But here the numerator is p minus 1. Therefore, p minus 1 has to be greater than or equal to 1. That means p has to be greater than 2. So if p is strictly greater than 2, then the series is convergent. If p is strictly greater than 2, then the series is convergent, right? So we have bn is equal to 1 by n power p minus 1, and we know this is convergent if the power is strictly greater than 1. So if power is strictly greater than 1, then p minus 1 has to be strictly greater than 1. That means p has to be strictly greater than 2, right? Therefore, for what values of p, this series is convergent. So this series is convergent if p is strictly greater than 2. The previous problem, p is strictly greater than 1, but in this problem, p is strictly greater than 2. Okay. So 11th problem. For what values the series is convergent? Again, for what condition the series is convergent? The question is 2 power p by 1 power q. Here we have two different numbers p and q. So 2 power p by 1 power q plus 3 power p by 2 power q plus 4 power p by 3 power q and so on. So what will be my nth term? So this is nothing but, so this is, I can see if n is equal to 1, we have 2. If n is equal to 2, we have 3. If n is equal to 3, we have 4. So in general, it is nothing but n plus 1 whole power p divided by n power q, right? N plus 1 whole power p divided by n power q. Now we will have un is n plus 1 whole power p divided by n power q. So I take n power p common. So this will be 1 plus. Actually, why I'm writing here? I'm writing this straight away. So because n plus 1 whole power p, right? Actually, I have to do like, I have to take n common here. So we will have 1 plus 1 by n whole power p. Now I can take p outside by taking n power p, and I can write this as, so I'm skipping one step, right? So I can take n power p outside and 1 plus 1 by n whole power p, and in the denominator we will have n power q. So you always take you always cancel it. Suppose if you have some n terms here, you bring that to denominator. So this will be 1 plus 1 by n whole power p divided by n power q minus p, right? If p is denominator. Now take vn. Vn is equal to n 1 by n power q minus p, right? Now what about limit n tends to infinity un by vn, and this is nothing but limit n tends to infinity un is 1 plus 1 by n whole power p divided by n power q minus p into vn. So vn is 1 by, actually if I take vn to numerator, we will have n power q minus p. So this two will get cancelled. So as n tends to infinity, this will be 1 power p, right? So this will be 0. So we will have 1 power p, which is finite and non-zero. Finite, and it is not equal to 0. So if summation vn is convergent, what is summation vn? Summation 1 by n power q minus p is convergent. If this is convergent, our series will be convergent, because by comparison test, since this is both finite and non-zero, if un convergent, vn is also if vn is convergent, un is also convergent, and this will be convergent if and only if q minus p has to be greater than 1, because summation 1 by n power p is convergent if p is strictly greater than 1, so the power has to be greater than 1. So whenever q minus p is greater than 1, then this series is convergent. The condition for the series convergent is that, so q minus p has to be strictly greater than 1, right? Q minus p has to be strictly greater than 1. So the series is convergent if q minus p is strictly greater than 1, and it is divergent if q minus p is strictly less than or equal to 1, less than or equal to 1. Now we will move on to 11th problem. Move on to 11th problem. The 11th problem is 1 plus 1 by 2 square plus 2 square by 3 square plus 3 square by 4 square plus 3 cube by 4 power 4, 2 cube by 2 square by 3 cube, 3 cube by 4 power 4, 4 power 4 by 5 power 5, and so on, right? Now if you omit, now if you see this series from this term, right, so just for now you just forget 1. Now can you write the nth term for this? You can easily write, right? So the nth term is nothing but n power n for numerator, so 2 2, 3 3, 4 4. So for the you just omit 1 as of now. Now you just write un for this term, so it is nothing but n power n. So if n is equal to 1, we will have 1 power 1, and if n is equal to 2, we will have 2 power 2. If n is equal to 3, we will have 3 power 3. If n is equal to 4, we will have 4 power 4 divided by, and here you can see this is nothing but n plus 1 whole power n plus 1, right? This is our series. Now you just omit 1. You just omit 1. You can omit because why? Leaving the first term, adding or deleting a finite number of terms does not alter the nature of series. We can omit 1. Actually we can also omit the first 100 terms. We can also omit the first 1 lakh terms. We can also omit the first 1 crore term, right? We can omit 1 because addition or deletion of finite number of terms does not alter the nature of the series, right? So a convergent series cannot be made a divergent series cannot be made convergent by adding a finite number of terms, right? So even if you add or delete a finite number of terms, the nature remains same, right? If it is divergent, even if you add 1 lakh term, there is no possible that this is convergent. If it is convergent, even if you add 1 lakh or 2 lakh term to make it divergent, it will not happen. So we can omit 1 because here we are only omitting 1 term, but we can also omit any finite number of terms. Also we can add any finite number of terms, this will not alter the nature of the series. So therefore you just omit the first term. Now consider only the series from this term. So our un is n power n divided by n plus 1 whole power n plus 1. So this is nothing but n power 1 n plus 1 whole power n into n plus 1. So I am just splitting the powers n plus 1. Now we will just take n power n outside here. So this will be 1 plus 1 by n whole power n into again you just take n here. This will be 1 plus 1 by n. This will get cancelled. So you just take Vn to be equal to 1 by n. So this will be 1 by n into 1 plus 1 by n whole power n 1 plus 1 by 1. So take Vn is equal to 1 by n. Now you find limit n tends to infinity un by Vn. So you will get finite and non-zero term. Finite and non-zero, because you can see this 1 by 1 will get cancelled. So here you will have 1 plus 0. The answer will be 1 by 1 power n plus 0 plus into 1. So this will be n term will be equal to 1, which is finite and non-zero. So both un and Vn behave alike by comparison test. Behave alike. So since what is Vn, which is 1 by n, this is divergent. Remember, as a sequence 1 by n is convergent, but as a series 1 by n is divergent. So this series is divergent. So therefore un is not convergent. This is divergent. So this is divergent. Un is also divergent because both behave alike. So un is also convergent. Sorry, divergent. Right. So this series is the divergent series. Move on to the 12th problem. So root 2 minus 1. So root 2 minus 1 divided by 3 cube minus 1 less root 3 minus 1 divided by 4 cube minus 1 less root 4 minus 1 divided by 5 cube minus 1 and so on. Now we will find the nth term of the series and then we will apply comparison test, right? Yes. Now you can see this is nothing but root n plus 1. So if n is equal to 1, you will have okay, and you can see 3 is fixed for all the term. So we can write un straight away, or also we can apply use a plus n minus 1d formula, which is said at the beginning of the video. This is nothing but root n plus 1 minus 1 divided by and 3, 4, 5. So you just find the nth term for 3, 4, 5 and so on. So a plus n minus 1 d. So d is 1. So 3 plus n minus 1, which is n plus 2. So this is nothing but n plus 2 whole cube. 3 is fixed for all the term minus 1. So this is our un. Right? Okay. So our un is root n plus 1 minus 1 divided by n plus 2 whole cube minus 1. N plus 2 whole cube minus 1 is 12th problem. Now we need to simplify this. We will do 1 by 1. How can we do? Okay, so what I will do is I will take root n common in the first term. So if we take root n common, So this will be square root of 1 plus 1 by n, and here we don't have root n, so we'll divide this by root n, right? So I can write the numerator as if I bring this to inside, you will get this term. So here we will have root n will get cancelled, so we have minus 1. And again, if I take n cube common here, so this will be 1 plus 2 by n whole cube, 1 plus 2 by n whole cube, and here we don't have n cube, so what we will do is we will divide this by n cube. Right? Yes. Now if you take this term to the denominator, you will have this term to be 1 by n power 3 minus 1 by 2, because this 1 by 2, so this will be 3 minus 1 by 2, which is n power 5 by 2, right? N power 5 by 2. So this term will remain here as it is, right? This term will remain here as it is. So you just take, now you take Vn. Vn is equal to n by n power 5 by 2. 1 by n power 5 by 2. So 3 minus 1 by 2 is something but 6 minus 1 by 2, which is 5 by 2. So this term will remain here as it is. Now you find limit n tends to infinity un by vn, and if you find this, you can see this term and this term will get cancelled. So we have only this term. Now as n tends to infinity, you can see this term tends to 0, this term tends to 0. So we have this term tends to 0 and this term tends to 1, and again this term tends to 1, this term tends to 0. So we will have 1 minus 0 by 1 minus 0, which is 1. So which is finite and non-zero. So we will have 1, this is equal to 1, which is finite and non-zero, right? So both summation un and summation vn behave alike. So since what is summation vn? So summation 1 by n power 5 by 2. This is convergent. Why? This is convergent because 5 by 2 is strictly greater than 1. 1 by n power p is convergent if p is strictly greater than 1. So here we have 5 by 2. So 5 by 2 is strictly greater than 1. So therefore, since summation vn is convergent, summation un is also convergent, right? So therefore the series is convergent. The series is convergent. Okay. Okay. So we'll do one more problem and then we'll wind off. We will do 2 more problems. So we'll do 13th problem and 14th problem and then we'll wind off, right? The next video we should continue. Actually, there are some more problems also left in a comparison test. So next video also we will discuss some more problems. So another 10 to 15 problems. Actually, our aim is to solve around 30 to 40 problems only on comparison test. Generally, you will get more practice and confidence. So far you have solved 12 problems. So I'll solve 2 more problems. And in the next video also we will continue comparison test. And then we'll move on to ratio test, right? Okay. So we'll move on to 13th problem. If you have any doubt, you can ask. So I think 2 is watching. Two members are watching. If there is any doubt, you can ask this because I will not be available after that. So 13th problem, discuss the convergence of the series. So 1 by 5 plus root 2 by 7 plus root 3 by 9 root 4 by 11 and so on. So I can also write 1 as root 1. So you can see clearly the numerator is something but root n. So our un is summation root n, and we can also find nth term, right? 5, 7, 9, 11 and so on. So nth term will be, so our a is 5 and the common difference is 2. So a plus n minus 1t. So this will be 5 plus 2n minus 2. So this is nothing but 2n plus 3. So this is nothing but summation root n by 2n plus 3. Okay. Now our un is root n by 2n plus 3. So let me take n common here. So we will have 2 plus 3 by n. So this I can write this as 1 by n power 1 minus 1 by 2. So I'm taking 1 by 2 to denominator. So we will have 2 plus 3 by n. So this is nothing but 1 by n power 1 by 2, 2 plus 3 by n. Now I will take Vn. Vn is equal to 1 by n power 1 by 2. Now what about limit n tends to infinity un by Vn? Which is limit n tends to infinity. So un is 1 by n power 1 by 2, 2 plus 3 by n divided by Vn. So as n tends to infinity, this will be 1 by 2, which is finite and non-zero. So both behave alike. So since summation Vn is divergent, why? Because summation 1 by n power p is convergent if p is strictly greater than 1. So here p is 1 by 2, which is less than 1. 1 by 2 is less than 1. So therefore summation un is divergent. This is divergent. So we'll move on to the final problem to answer on this video, which is 14th problem. The 14th problem is 2 square by 3 square plus 2 square minus 4 square, 2 square minus 4 square divided by 3 square minus 5 square plus 2 square minus 4 square minus 6 square divided by 3 square minus 5 square minus 7 square and so on. Now you can see it is very hard to write the nth term, right? Because every term is a summing up. Every term we are adding some terms, right? We are not multiplying, we are adding some terms. So we need to find the nth term now. Okay. And you can see I can write un as summation un as, okay, we will first find the nth term. So nth term is, you can see 2 square minus 4 square minus 6 square and so on. So this is stopped up to 2n, right? So if n is 2, it stops at 4. If n is equal to 3, it stops at 6. So this stops at 2n whole square divided by and here it goes on 3 square minus 5 square minus 7 square and so on. So if n is equal to 2, this stops at 5. That means it stops at 2n plus 1 whole square, right? So if we put n is equal to 1, we will have this term. So if n is equal to 2, we can go up to 4 square. So we have 2 square minus 4 square. If n is equal to 2, we have 5 square. So it's up to 5 square. If n is equal to 3, we can go up to 6 square. So 2 square minus 4 square minus 6 square. If n is equal to 3, we can go up to 7 square. So this is our nth term. So our nth term is 2 square minus 4 square minus 6 square up to 2n square. And actually first we will solve this by comparison test now. But after studying a ratio test, we can quickly solve this in a fraction of a second when we apply ratio test here. But since we are solving only the problem based on comparison test, we will do this sum in bit more complicated. But if you do this in ratio test, we can quickly do this in 1 or 2 minutes. But we try to do this in comparison test, right? We try to do this in comparison test. If you apply ratio test, we will apply answer in 1 or 2 minutes. So okay, no problem. We will do this in comparison test. We can approach the same series by any test. So 2 square minus 4 square minus 6 square by 2n square divided by 3 square minus 5 square by 7 square up to x. Now what I am going to do is I am going to write this as so I am going to write this series as 2 into 2 square 2 square plus 4 square plus 6 square and so on 2n square divided by minus divided by 2 into 3 square minus 3 square plus 5 square plus 7 square and so on up to. Now you can see I have changed the sign. So everything is minus here or everything is plus here. So I have taken 2 into 2 square. I have written this as 2 into 2 square minus this term. You can easily verify this term is 4. Actually this term is 4. Now if you subtract 2 into 2 square minus 4, we will have 2 square. If we subtract 2 into 2 square with 4 square, we will have minus 4 square, right? So I am writing this term like this. Now this I can write this as, so 2 into 2 square is 8. So 8 minus summation this is nothing but summation 2n whole square divided by, this is 18. So 18 minus summation 2n plus 1 whole square. Summation 2n plus 1 whole square. Right? Yes. Now this is equal to 8 minus, so if I take 2 square outside, this will be 4 into summation n square divided by 18 minus, and if I apply a minus b whole, a plus b whole square formula, so first you will have a square, so which is 4n square, so 4n square, since you have minus here, so I am writing every term with minus, so a square plus b square, so a square plus 2ab, so plus 2ab will be minus here, so 2 times ab, so 2 into 2n into 1, so we will have 4n, so we will write this, I'll take 4 outside, so n 4n plus b square, so which is summation 1, right, summation 1, right. So now just I expanded this in a plus b whole square formula, so a square minus 2ab plus b square, and summation 1 is nothing but n, right, summation 1 is nothing but n. Okay, we will do this next step. So this is nothing but 8 minus 4 into, so summation n square, so these are very basic formulas. So summation n square is n into n plus 1 2n plus 1 by 6, n into n plus 1 2n plus 1 divided by 6 divided by 18 minus 4 into, so again n square is n into n plus 1 2n plus 1 divided by 6 minus 4 into summation n is n into n plus 1 by 2 and summation 1 is equal to n. Now you need to simplify this entire term, right? You need to simplify this entire term. So I will straight away write the answer. You will get the entire term as, you will get the entire term as, after all the simplification, right, you will get the entire term as 4 plus 6 by n plus 2 by n square minus 24 by n cube divided by 4 plus 12 by n. So you just take all the highest term and then cancel it out, you will get this term, right? 4 plus 12 by n plus 11 by n square minus 54 by n cube. This is our un, right? Actually so far what we have did is we have find the nth term only like this. Now what about limit n tends to infinity un? As n tends to infinity, this tends to 0, this tends to 0, this tends to 0, 0, 0, 0. So we have left it with equal to 4 by 4, which is equal to 1, which is not equal to 0. So what can we say? If it is equal to 0 only, then we can check for comparison or any test, then only it may or may not be convergent. But since this is not equal to 0, summation un is divergent. Summation un is divergent, right? Yes. So actually I have written the answer straight away. Only thing is it is the child's play, right? Only have to multiply and then you take the highest power outside and then cancel it out, you will get this term. As n tends to infinity, this does not tends to 0, that means it is not convergent, right? Yes. So the next video I will continue solving some more problems on a comparison test. That's it. Thank you. We will see next video also problem based on comparison test.